Hello everybody. So in this session we are going to talk about the basics of polynomials. So let us start with it. So before actually starting what is a polynomial, we must know about variables and constants, and I'm sure you already know about that. Let us revise that quickly. So variables are the unknowns. They are the unknowns. So you use the letters X, Y, Z, A, B, C, D, any letter of the English alphabet to represent variables, right? The unknowns are the variables and the constants are the fixed things. For example, every number is a constant. Any rational or irrational number, that is a constant. You don't have to bother about that, whether it is rational or irrational. So something having fixed value is a constant in math, and something of which you don't know the exact value, that is a variable. The word variable is coming from this thing. You can see vary and able, like it is able to be varied. You can do the variation in that basically. So let's move on to the next thing. So what are terms and number of terms? So what is a term? So for example, I'll write it like this. See, you'll get it immediately. These are the basics. So if somebody asks what are the terms over here? So basically parts of an algebraic expression. We will study about algebraic expressions as well. Parts of an algebraic expression separated by addition or subtraction sign. So you see, this is a term over here. This is another term. This is another term. So 5x square y is a term. 8xy is a term. 9 is a term. These are the terms over here. Fine. So for example, if I'm writing minus 8x cube y plus 3xy square minus 7. So what are the terms over here? Parts of an algebraic expression separated by addition and subtraction sign, they are the terms. So over here you see, this is a term, this is another term, this is another term. So basically minus 8x cube y, 3xy square and minus 7. These are the terms over here, right? Parts of algebraic expressions separated by addition or subtraction sign. Now over here something called like and unlike terms, that you also know. Let us see that quickly. Like and unlike terms. Unlike terms. So like and unlike terms, I'll just explain using an example. For example, if I have got 5xy comma minus 8 by 3xy. So these are like terms. Why they are like terms? Because you see, they are having same variables over here, same variable x and y over here, and the exponent of each of the variables, they are same. The exponent of each of the variables, they are same. Then you will say that they are like terms over here. Now suppose if I write 5xy and 5xy square, are these like terms? No, they are not like terms, they are unlike terms, because the variables are same. Variables are same, but exponent of variable, they are different. This is 1 and 1 and this is 1 and 2. So exponents of variables are different. So they are unlike terms over here. They are not like terms. Now the order does not matter. For example, if I've got minus 8 by 3 x square y, I'll write over here, wait. And then 5 yx square. If somebody asks, are these like terms? Yes, they are like terms over here, because you see, variables are same and exponent of x and y, they are same. So they are like terms over here. Order does not matter because multiplication is commutative, that you already know. So that is the meaning of like and unlike terms. Now over here, you know about the number of terms, and on the basis of the number of terms, you decide something called monomial, binomial, trinomial, right? So for example, I give a small question over here. I give a small question like 3x square plus 8 minus 5 x square y. Suppose something like that. This is also x square y. So is it a monomial, binomial or trinomial? So the answer to it is, it's not a trinomial. I'm taking this simple example because many students, they just quickly go to the conclusion. It's not a trinomial. You have to first simplify. You see, these are like terms, so they can be combined. You will get minus 2x square y plus 8. So it is basically a binomial. It's not a trinomial, right? Now after this, you have got algebraic expressions, which we have already seen in the previous slide. So if you take various terms over there and combine them, it will be an algebraic expression. For example, if I've got 5x raised to the power minus 8y plus 7x square y plus 3. It's an algebraic expression because it's a combination of variables and constants, right? A combination of variables and constants. So it is expressing something in algebra. So it is an algebraic expression. Like expressing something in algebra means if you put some values of it, it might explain some situation, right? So it is expressing something in algebra, so it's an algebraic expression. Now, what about polynomials? What is a polynomial? That is the specific type of algebraic expressions. For example, you'll understand using examples over here. You see, for example, if I ask, is this a polynomial? The answer to it is no, it's not a polynomial. The answer to it is no. Now suppose if I ask, is this a polynomial? The answer to it is no, it's not a polynomial, right? Now suppose if I ask, is this a polynomial? Yes, it's a polynomial. So what is the definition of a polynomial? A polynomial is an algebraic expression having whole number exponent of variables. A polynomial is an algebraic expression having whole number exponent of variables. Whole number exponent of variables. So it can only have whole number exponent of variables, both the things. Whole number means starting from 0, 0, 1, 2 and so on. These exponents can be there and it must be of variables. You are not talking about constants. Whole number exponent of variables, not constants. So many students, they get confused in that thing. Therefore, I'm writing over that exclusively. So whole number exponent of variables must be there. For example, why third one is a polynomial? See the exponent of the variable. This is not a variable, so you don't have to bother about it. So only whole number exponent of variables must be there. Over here, whole number exponent of the variable is there. Therefore, this is a polynomial. I hope that one is clear. Over here, the exponent of the variable is fractional. Therefore, it's not a polynomial. Over here, the exponent of the variable is negative, therefore it's not a polynomial. And one more thing is there, infinite number of terms cannot be there. For example, if you are taking suppose 5x raised to the power 100, suppose 3x raised to the power 99 and so on, and you have put these three dots, what does it mean? That it is going on up till infinity. Now you might argue over here that it's having whole number exponent of variables, but is it a polynomial? No, because it's having infinite number of variables. A polynomial will have finite number of terms. I'm sorry, not infinite number of variables. I'm talking about infinite number of terms. So a polynomial cannot have infinite number of terms. It must have whole number exponents of variables and it must have finite number of terms for an algebraic expression to be a polynomial. Now one thing is degree of a polynomial. So that is the highest exponent of the variable, right? Highest exponent of the variable. So the highest exponent of the variable is the degree of a polynomial. For example, suppose I'm taking a polynomial p of x. You represent a polynomial like this. It means polynomial in variable x. You can also represent it like this: g of x, f of x. It is not hard and fast to take p of x only, right? Now suppose I'm taking a polynomial over here. So what is the degree of this polynomial? The degree of this polynomial is 4. The highest exponent of the variable in the polynomial is its degree. Highest exponent of the variable is the degree of a polynomial. Now suppose a polynomial can also be in two variables. You see, like this, we call it a bivariate polynomial. It can be trivariate polynomial, 3 variables as well, right? Although that is not there up till grade 10, but in the basics of polynomials, you must know these things. So for example, I have got something like this. So what is the degree of this polynomial? You see, you might be directly seeing and you can say 3, but that is not the degree. Because you see, two variables are multiplied. This is 3. Over here, 2 plus 2, 4. This thing is giving 4. And this is 2. So therefore, the degree of this polynomial is 4. That's how you decide degree of a polynomial when it's a bivariate polynomial. Bivariate, trivariate, whatever it can be there, more than one variable, right? It's a bivariate polynomial. I hope that one is clear. Now, one or two more things are there in degree of a polynomial. For example, somebody might ask, what is the degree of this polynomial? It's a non-zero constant polynomial. Non-zero constant polynomial. Now you see, somebody might say that it is 2 raised to the power 1 by 3, 1 by 2, so the degree is half. But that is not the degree, because the degree is the exponent of the variable, right? So therefore, we can obviously write it x raised to the power 0. Anything raised to the power 0 is 1, except 0 raised to the power 0. 0 raised to the power 0 is not 1. 0 raised to the power 0 is an indeterminate form. You'll study about it in grade 11. Obviously, you can prove it that 0 raised to the power 0 is not 1 using laws of exponents. I'm not doing it over here because that is not the purpose of this lecture, right? So the degree of any non-zero constant polynomial is 0. Degree of any non-zero constant polynomial is 0. For example, if you have got, suppose, something like this, 8 by 3, you can obviously write it like this: 8 by 3 x raised to the power 0. So degree of any non-zero constant polynomial is 0. I hope that one is clear, right? Now if somebody asks, what is the degree of the zero polynomial? So you see, you can write it like this. If you want, you can write it like this as well. You can write it like this as well. So basically, you are not able to assign a unique value to the degree of a zero polynomial. You see, you can write it like this, like this, like this, like this. That is not possible. So because the degree has to be a unique value, single value. So the degree of a zero polynomial is not defined. Degree of zero polynomial is not defined over here. I hope that one is clear. Now, one or two things which you need to understand is, which you already know, but still you have to see. For example, if you have got linear polynomial, so its degree is 1. For example, if it's a quadratic polynomial, it means degree is 2 over here. In the same manner, if it's a cubic polynomial, then degree is 3. Similarly, if it's a quartic polynomial, then degree is 4. And if it's quintic polynomial, then degree is 5, and so on, right? And so on. After that, I don't remember, and that is nobody is going to ask that thing. I mean, even after cubic, they will just write that it's a polynomial of degree 4 or degree 5, something like that. Now, let us take some examples. Linear polynomial. For example, if I take something like this, you see, this is a linear polynomial in one variable or not? Because the highest exponent of the variable is 1. Degree is 1 over here. You can also have a linear polynomial in two variables. For example, you see, this is a linear polynomial in two variables, something like this. Similarly, you can have a quadratic polynomial as well. This is a quadratic polynomial in 1 variables. You can have a quadratic polynomial in 2 variables as well. Similarly, you can have a quadratic polynomial in 3 variables, in 4 variables, and so on. And the same will happen with cubic polynomials as well as quartic as well as quintic polynomials. So I hope these things discussed with you, they are very clear, because these are the basics of polynomials, and the knowledge of these things are very important when you move to grade 9 or to grade 10 or even in grade 11 as well. So I hope these things discussed is clear. And don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. I'm Misbah, your maths educator. We'll meet in the next concept video. Bye-bye guys. Take care everybody.